the precise definition of a limit. Here we have this definition. Let f of x be defined on an open interval above c, except possibility at c itself. We say that the limit of f of x as x approaches c is the number L. So writing limit of f of x as x approaches c is equal to capital L. If for every number epsilon greater than 0 there exists a corresponding number delta greater than 0 such that absolute value of f of x minus L less than epsilon whenever absolute value of x minus c between 0 and delta. So what this part means, for every number epsilon there exists delta. This means delta depends on epsilon. Here I have possible graph of a function. Here we have x naught is c, and here for limit of f of x as x approaches c, that is equal to capital L. Drawing these horizontal lines, here what we have between L and L plus epsilon is epsilon, and f of x lies in this interval between L minus epsilon and L plus epsilon. And here I draw vertical lines. So what I did first for drawing horizontal lines, I used this point on that part and draw a line from this capital L, this horizontal line, and did same thing for this point x naught. So I used that point and this one to connect these two and cross the point that I have here on this curve. And then based on what we have for epsilon, so for every epsilon we're trying to find delta. So based on what I have here and the definition we have here on top, for every number epsilon there exists number delta greater than 0. So now here this part of curve that is between these two vertical lines, and what we have for that part is between these 2 points. The point is that this part of curve should fit in this interval. If not, if, for example, if we try to make this part narrower, that means this part should be narrower too. And also if this part didn't fit in what we have here for this part, we should make this interval smaller. So that way this curve will fit in what we have for this part. So delta is the distance between C and N points. So here in this case we have our interval is C minus delta, C plus delta. So delta is what we have starting from center, moving to the left, and same thing starting from center, moving to the right. That is our delta. We can present in matching distance delta that keeps x close enough to C to keep f of x within that epsilon tolerance of capital L. This leads us to the precise definition of a limit. Examples: use the graph to find E delta greater than 0 such that absolute value of f of x minus L less than epsilon whenever absolute value of x minus c between 0 and delta. So first step is to find over interval absolute value of x minus c less than delta. So what we have here underscored, that's -3, that is c. So using that number here inside absolute value, and now solve for x. So this implies, here we have negative times negative is positive, so inside absolute value we have x plus 3. Because of having absolute value, here what we have inside absolute value x plus 3 is less than positive delta and greater than negative delta. Now this implies solving for x. X is between delta minus 3 and negative delta minus 3. Now step 2, what we have from the graph for negative delta minus 3. That is equal to this number, negative 3.1. So solving for delta, that is equal to 0.1. Or what we have here on right side, delta minus 3, that is equal to this number, it's negative 2.9. So solving for delta, that is equal to 0.1. That means the answer for delta is 0.1. Now here on this graph, what we have for c is 3, and step 1 is absolute value of x minus c less than delta. So c is 3. Now solving for x, this implies x minus 3 between negative delta and positive delta. That implies x between negative delta plus 3 and positive delta plus 3. Now from the graph, negative delta plus 3 is equal to 2.61. Solving for delta, that is equal to 3 minus 2.61, so it's 0.39. Or here we have delta plus 3, and that is equal to this point, 3.41. Solving for delta, the answer is 0.41. In this case, we have different numbers for delta. That means the distance that they have here between these 2 points is smaller than what we have for that part. And we have to use the smallest distance between C and the endpoints of the interval. So that means our answer for delta is 0.39. So use the smallest. Distance. Between C and these 2 points. So the answer for delta is 0.39. Now here in this graph, our C is 2. So using absolute value of x minus C less than delta, here we have absolute value of x minus 2 less than delta, solving for x. So what we have inside the absolute value, x minus 2 is between negative delta and positive delta. That implies solving for x is between negative delta plus 2 and positive delta plus 2. Step 2 from the graph, negative delta plus 2, that is equal to radical 3. And solving for delta, delta is equal to 2 minus square root of 3. So using calculator, my answer for this part is 0.2679. And here what we have on the right side, delta plus 2, that is equal to square root of 5. This implies delta is equal to square root of 5 minus 2. And the answer is rounded to for decimal place. We have 0.2361. Between these two numbers, the number that is smaller is 0.2361, meaning that the answer for delta is square root of 5 minus 2. How to find algebraically delta for a given function, capital L, C, and epsilon greater than 0. To process of finding a delta greater than 0 such that absolute value of f of x minus L less than epsilon whenever absolute value of x minus C between 0 and delta is by following these two steps. Step 1, we have to solve inequality, absolute value of f of x minus L less than epsilon. So this way we are able to find an open interval a comma b containing C on which the inequality holds for all x not equal to C. Note that we do not require the inequality to hold at x equal to C. It may hold there or it may not, but the value of f at x equal to C does not influence the existence of a limit. So what we have is for all when x is not equal to C. Step 2, find the value of delta that places the open interval centered at C inside the interval AB. So that means the inequality absolute value of f of x minus L less than epsilon will hold for all x not equal to C in this delta interval. Example, for the given function f of x and values of L, C, and epsilon, find the largest open interval above C on which the inequality absolute value of f of x minus L less than epsilon holds. Then determine the largest value for delta such that absolute value of x minus C between 0 and delta implies absolute value of f of x minus L less than epsilon. So what we have here, our function f of x is equal to 4x plus 2. L is 22, C is 5, and epsilon is 0.24. So here we have to solve absolute value of f of x minus L less than epsilon. In this case, f of x is 4x plus 2. So we have absolute value of 4x plus 2 minus L is 22 less than epsilon is 0.24. So what we have here inside absolute value, that is between negative 24 and positive 24. Now solve for x. So this implies, here we have 2 minus 22, it's minus 20. So 4x minus 20 is between negative 0.24 and positive 24. Solving for x, here we have to add 20 to all of these. So here 20, add same number to left and right side. So for x is between 19.76 and 20.24. Next step, we have to divide by 4 all of these. So x is between 19.76 divided by 4 is 4.94. And here we have 20.24 divided by 4 is 5.06. So this is our interval. And now we can find delta based on these two numbers. So finding delta, we have to find C minus delta and C plus delta. We have these numbers here. So that is, our C is 5. We have to find delta, and this is equal to this number, 4.94. Now solve for delta. Delta is equal to 5 minus 4.94. So delta is 0.06. And using this part, which is what we have on the right side of our interval, instead of C, what is given here on top, it's 5 plus delta, that is equal to this number, 5.06. This implies delta is equal to 5.06 minus 5. So delta is 0.06. So what we did on this part, we tried to find the distance from 5 to either end point of the interval. Because of having same number for delta, our answer for delta is 0.06. Another example, for the given function f of x and numbers L, C, and epsilon, find an open interval above C on which the inequality absolute value of f of x minus L less than epsilon holds, then give a value for delta such that for all x satisfying absolute value of x minus c between 0 and delta, the inequality absolute value of f of x minus L less than epsilon holds. So our function here on the spot f of x equal to square root of 19 minus x over L is 3, c is 10, epsilon is 1. Here again we have to solve absolute value of f of x minus L less than epsilon. In this case f of x is square root of 19 minus x. So we have absolute value of square root of 19 minus x minus L is 3 less than epsilon, which is 1. Now solve for x. This implies what we have inside absolute value is between -1, +1 at 3, that is square root of 19 minus x between +2 and +4. Now next step, we have to eliminate this square root by using power. So I have to use second power. For all of these, we have 2 squared. And here we have this power for this part. So that way we can eliminate this square root. So we have 19 minus x. And on this side we have 4 squared. So that is 16. Now solving for x. So subtracting 19. And finally divide by -1. And change the direction of inequality. So we can write this way, or x between 3, 15. So these two numbers, 3, 15, are the end point of our interval. Now we can find delta. So this is our interval. What we have for c minus delta, we have 3. And what we have for c plus delta, it's 15. So using these, we have ten minus delta, because our c is 10. So 10 minus delta is equal to 3. Solving for delta is equal to 10 minus 3. And that is 7. And on the right side we have c plus delta, c is 10. And that is equal to 15. Delta is 15 minus 10, and the answer is 5. We have to use the smallest distance between c and the endpoints of the interval 3, 15. So in this case, the smaller number is 5. So that means our delta is equal to 5. Example, for the given function f of x and the given values of c and epsilon, find limit of f of x as x approaches c equal to L. Then determine the largest value for delta such that absolute value of x minus c between 0 and delta implies absolute value of f of x minus L less than epsilon. Here on this part, f of x is equal to x squared plus 7x plus 6 divided by x plus 6. C is -6, epsilon is 0.2. Here, first, we have to find the value of the limit and simplify this expression. So L equal to limit of this function as x approaches c, in this case c is -6, that is equal to limit. If we use -6 instead for x, we will have 0 divided by 0, and that way we're not able to find the answer, so we have to factor what we have in numerator. So we have x plus 1 times x plus 6 divided by x plus 6. We can cancel x plus 6 from numerator denominator. So what's left? Limit of x plus 1 as x approaches -6. That is -6 plus 1 equal to -5. So here on this part, we didn't have L given. That's why we had to find this part first. And now we are able to solve absolute value of f of x minus L less than epsilon. So solve absolute value of our function is x squared plus 7x plus 6 divided by x plus 6 minus L is -5. So this absolute value is less than epsilon is 0.2. From what we did here on top, we factored and we had x plus 1 after canceling x plus 6 from numerator to denominator. So I'm using this x plus 1 here. And then negative times negative, we have positive 5. This absolute value is less than 0.2. So absolute value of x plus 6 is less than 0.2. What do you have inside absolute value? This is between -0.2 and positive 0.2. Solving for x, subtract 6. So x is between -6.2 and -5.8. Now we have to find delta, so finding the distance between c and the endpoints of our interval, which is -6.2 and -5.8. So what we have here, c is given, that is -6, so -6 minus delta is equal to negative 6.2. Solving for delta, that is equal to 6.2 minus 6, so the answer is 0.2. And what we have here on the right side, c plus delta, c is negative 6. That is equal to this number, negative 5.8. Here again, delta is 0.2. That means delta is 0.2. Here we have to prove that limit of square root of x minus 3 as x approaches 84 is equal to 9. So to prove this part, we have to show that for all x, if absolute value of x minus 84 between 0 and delta, then absolute value of square root of x minus 3 minus 9 is less than epsilon. So we have to solve the inequality to find an open interval above c is c equal to 84, on which the inequality holds for all x not equal to c. So here, solving absolute value of square root of x minus 3 minus L, so that is over L, less than epsilon. When we have inside that absolute value, that is between negative epsilon and positive epsilon. Now solving for x, now here we have to add 9. And here we have square root, so we have to eliminate by using second power for all of these. So what we have, x minus 3 is between 81 minus 18 epsilon plus epsilon squared, and 81 plus 18 epsilon plus epsilon squared. Now solve for x by adding 3 to all. So adding 3, we have 84 minus 18 epsilon plus epsilon squared. And here 84 plus 18 epsilon plus epsilon squared. Now that we have our interval, we can find delta. So take delta to be the distance from C, which is 84, to the near endpoint of our interval. So delta is the smallest number that we can have, minimum of. Finding distance. So C is 84 minus what we have here. Our endpoint is 84 minus 18 epsilon plus epsilon squared. And here we have absolute value of C minus 84, what we have here on the right side. So it's 84 plus 18 epsilon plus epsilon squared. So I simplified what they had here, this absolute value. So delta S minimum of absolute value of 18 epsilon minus epsilon squared and absolute value of negative 18 epsilon minus epsilon squared. So our delta S absolute value of 18 epsilon minus epsilon squared. So if delta has a value of absolute value of 18 epsilon minus epsilon squared or any smaller positive value, the inequality absolute value of x minus 84 between 0 and delta automatically places x between what we have for our interval to make absolute value of square root of x minus 3 minus 9 less than epsilon. Since there exists such a value of delta, the limit as x approaches 84 of the function square root of x minus 3 is 9. Prove that limit of 1 over x squared as x approaches square root of 3 is equal to 1 over 3. We have to solve the inequality absolute value of 1 over x squared minus 1 over 3 less than epsilon. So what we have inside absolute value is between negative epsilon and positive epsilon. Now add 1/3. So 1 over x squared is between negative epsilon plus 1/3 and epsilon plus 1/3. Now simplify what we have here on left and right side using 3 as a denominator. Now what we have is 3 times epsilon plus 1. And here same thing, our denominator is 3. And we have 3 times negative epsilon plus 1. Now x squared by moving x squared to numerator, that means we are going to change the direction of inequality. So here we have 3 divided by 3 epsilon plus 1, and here on left we have 3 divided by negative 3 epsilon plus 1. Now here we have to eliminate this power. So using square root. Square root of x squared is x. And here using square root of 3 divided by 3 epsilon plus 1. And here on the side, again, square root. So the inequality absolute value of 1 over x squared minus 1/3 less than epsilon is true for all x not equal to square root of 3 in the open interval. So our open interval is square root of 3 divided by 3 epsilon plus 1, comma, square root of 3 divided by 1 minus 3 times epsilon. So delta is smallest distance between C and N points in our interval. So delta is minimum of absolute value of square root of 3 minus square root of 3 over 3 times epsilon plus 1, and absolute value of square root of 3 minus square root of 3 divided by 1 minus 3 times epsilon. We have to simplify these two to be able to find the smallest delta. So the one that I have here on left, absolute value of square root of 3 minus square root of 3 divided by 3 epsilon plus 1, that is equal to absolute value of square root of 3 minus, here in numerator we have square root of 3 and in denominator we have square root of what we had here on upper 3 times epsilon plus 1. Now factor out square root of 3. So we have square root of 3 times absolute value of 1 minus 1 over square root of 3 epsilon plus 1. Do the same thing for what we have here on the right side. Absolute value of square root of 3 minus square root of 3 divided by 1 minus 3 epsilon. So absolute value of square root of 3 minus square root of 3 divided by 1 minus 3 times epsilon, that is inside the square root. And now factor we have square root of 3 times absolute value of 1 minus 1 over square root of 1 minus 3 times epsilon. So after we simplified, now we have to compare these two distances that I have here for delta. So using what we have here in denominator, based on that epsilon is between 0 and 1/3. So that implies that 3 times epsilon is between 0 and 1. So that means what we have here on this part, this one on left, that is less than what we have here on right side. So what we have here, square root of 3 times absolute value of 1 minus 1 divided by square root of 3 times epsilon plus 1 is less than square root of 3 times absolute value of 1 minus 1 divided by square root of 1 minus 3 times epsilon. This means the value of delta is square root of 3 times absolute value of 1 minus 1 divided by square root of 3 times epsilon plus 1. Therefore, for any epsilon greater than 0, absolute value of x minus square root of 3 between 0 and square root of 3 times absolute value of 1 minus 1 divided by square root of 3 times epsilon plus 1 implies that absolute value of 1 divided by x squared minus 1 divided by 3 is less than epsilon, which proves the limit statement. Prove that limit of f of x as x approaches 2 is equal to 4 if f of x when x is less than 2, that is equal to 14 minus 5x, and f of x is 3 times x minus 2, that is when x is greater than equal to 2. So to prove, we have to show that for all x, if absolute value of x minus c, in this case c is 2, between 0 and delta, then absolute value of f of x minus l less than epsilon. Here, what we have, f of x is 14 minus 5x, minus our l is 4. So absolute value of 14 minus 5x minus 4 less than epsilon, and here we have 3x minus 2, that is f of x, when x is greater than or equal to 2. So use that, subtract L, this absolute value should be less than epsilon. So solve these two inequalities. Here we simplify like terms, so 14 minus 4 is 10. We have 10 minus 5x inside absolute value, that is less than epsilon. But we have inside absolute value 10 minus 5x is between negative epsilon and positive epsilon. Now solving for x, subtracting 10, divide by negative 5, because of dividing by negative number, we have to change direction of inequality. So divide by negative 5 here. We have on this side we have 2 minus epsilon divided by 5, and here on the side we have 2 plus epsilon divided by 5. So what that means, here we have this interval now solving absolute value of 3x minus 2 minus L, which is 4, less than epsilon. So here we have absolute value of 3x minus 6 less than epsilon, 3x minus 6 between negative epsilon and positive epsilon, add 6, divide by 3, so our open interval is 2 minus epsilon divided by 3 and 2 plus epsilon divided by 3. So both of these intervals are centered on x equal to 2. Since this interval is fully contained within the interval that we have here on the right side, absolute value of f of x minus L less than epsilon holds for all values of x not equal to 2 within this smaller interval. So what we have here, delta is the distance from C, which is equal to 2, to the nearer endpoint of our interval. So delta is equal to minimum of absolute value of 2 minus. So this 2 is C, 2 minus epsilon divided by 5. So this one is inside absolute value, comma, absolute value, 2 minus what we have here on the right side, that is 2 plus epsilon divided by 5. So simplifying what we have here, delta is epsilon divided by 5. So here on this part we have absolute value of epsilon divided by 5, so that is epsilon divided by 5, and here on the right side we have absolute value of negative epsilon divided by 5, so that is again positive epsilon divided by 5. If delta has a value of epsilon divided by 5 or any smaller positive value, then equality absolute value of x minus 2 between 0 and delta automatically places x between our interval. So our interval was 2 minus epsilon divided by 5 and 2 plus epsilon divided by 5. To make these two inequalities, since there exists a value of delta such that this absolute value of x minus 2 is between 0 and delta, that makes our inequalities true for all x. The limit as x approaches 2 of the function, this function that was given, that is 4. So the limit is 4, and we proved what was asking us.